Okay, so we're back now. Let's see. So in this example, we saw just a nice vertical line. So we would just consume all bananas no matter what. Okay, so let's see another example. So we saw this example during class. And so the idea here was we saw the utility of A and B is 2 times the log of A plus the log of B. And we just set both prices equal to 1 to try to keep life a little bit simpler. And so just as a reminder, and this is a sort of key hint for this problem, is we saw earlier on that based on the utility function, this person will always spend 2/3 of their money on apples. And then we asked, of course, what is this person's income offer curve? Um, so we also asked, what is the slope of the IOC if you have time. I'm just going to breeze through this because we spent a fair amount of time on it before. Um, so we said, okay, well, what if they have an M of 3? Well, if they have an M of 3, then they can afford to spend $2 on apples, which is enough to buy 2 apples. So that would lead to a bundle of 2/1. Similarly, if they had $6, they could buy a bundle for 2. And so we see that the IOC is going to go through 2/1, 4/2, 6/3, 8/4. These are all the bundles where someone is spending 2/3 of their income on apples. So for the slope, for example, if you go from 2/1 to 4/2, well, the slope is the rise over the run, which is equal to a half. So that's where we would calculate the slope. Okay, and here's just a picture of that income offer curve with a couple of points labeled. Okay, so let's see another example. So in this example, we see that J has a utility function of the minimum of A and B, and the price of apples we assume is 1, and the price of bananas is 3. So okay, so remember this utility function. This is something that we've seen before. This is the perfect complements utility function. So, the example we've used a lot in class is like right shoe, left shoe. So, just the idea to keep in mind is, if you have 7 left shoes, or say, 7 apples and like 3 bananas or 3 right shoes, then you have like 3 full pairs, and then you have 4 pieces of trash that you just throw in the garbage can, and you get no value whatsoever from those sort of extras. So the question would be then, what is J's indifference curve? And again, this would be a small group, or for the purpose of today, some individual work. And try to execute this same plan that we've been using, right? Which is to say, look, it's really hard to do all at once, all of the different values of M, right? This problem is asking about every single value of M. That's hard. One thing that's a lot easier is to say, look, we're not going to deal with every value of M. We're going to pick something that we think is going to be easy, do that, and then hopefully that's going to give you some insight, right? If that doesn't give you some insight, it might be worthwhile to do that again. Try that again with a different value of M. And soon you're going to hopefully see a pattern and sort of see how the problem operates. Okay, so I'll give you a second now to do this in small groups, or individually rather. Okay, so now I'm going to assume that you're back and that you've spent a minute or two trying to really think through this problem. There's a lot of value in doing that, by the way. I think it's really much more valuable to spend the time and work on your own, and then you can come back and sort of see a solution to the problem. It's a lot better than just seeing the problem, seeing a solution, and without ever really thinking about it for yourself. Okay, so let's do what we always do, or at least what we've been doing lately, is to take one specific value of M and just try that out, right? So we'll say, okay, what if M is equal to 4? Okay, so what are some possible bundles that someone could consume if M is 4? Well, you could do 4/0. You could spend all your money on apples. You could spend all your money on bananas. You get 4/3 of a banana. or it works out that you could do 1 apple and 1 banana. So as a little side note, by the way, I did sort of pick the value 4 because I wanted it to equal 1 apple and 1 banana. And that's totally fine. When you're picking these values of m, you can try to be a little strategic. Get something that's where the math is going to work out nicely, or you think it's going to shed some sort of light on the problem. That's of course totally um, allowed, and in fact recommended. That's a good way to help yourself sort of figure out what's going on in a problem. Okay, so here are some possible bundles. Well, you get no utility for all apples. You get 1 utility if you get 1 apple and 1 banana. You get no utility for 0 and 4/3. And so the conclusion that we want to draw here is just that if you have a different number of apples and bananas, then this is not an optimal bundle. It just means like you're wasting some money. And you should be, say you have more bananas, you should just shift a little bit of money from bananas to apples. And that's always true as long as you have a different number of apples and a different number of, compared to your bananas. Okay, so we've seen sort of similar results before about this, just that you want to buy these items in pairs, right? So the idea here is that on your IOC, you're going to see 1, 1, 2, 2, 3, 3, all of those different goods, and just they have just the IOC will have a slope of 1, and so this is what that IOC would look like in this example. It's just like, an upward sloping line. You can think about y equals x or something like that. Okay, so let's take a pause here. I'm gonna pause the video, give everybody a chance to sort of take a quick break. And yeah, so let's pause the video right here.